So I will take the example of a very simple exercise, which is sentiment analysis. And that is the general example that I will take to explain how this kind of a workflow is getting framed. So sentiment analysis is the use case where I give you a sentiment, I give you a particular review. Imagine you go to some e-commerce portal and you buy something, you go to Amazon and you buy something, you go to Flipkart and you buy something, and after that you write a review. So based on whatever you purchased, you write a review, and based on the review, the brands, the company brands or Amazon in this case, will try to predict what is the sentiment of your review. Okay, so let's say you buy some product or service and you're not happy with the product or service, or there's some defect in the product or service. You will go and contact Amazon support, or you will write a big email, big lengthy review email, and you will send it to Amazon support. So based on that email, the team will review what is the sentiment of that email. Okay, the team will review what is the sentiment of that email. Is the email positive sentiment? Is the email negative sentiment? And maybe if it is negative sentiment, Amazon will give you more priority or more preference, right? So they will try to resolve your issue faster because it's an escalation kind of thing. So that is the idea. That is the workflow that we are trying to create. And again, something I mentioned in the last session also, that classification task is not a new thing. This is something we've been doing for a long time. It is not that this is possible only with large language models. We already have traditional methods using which we could do something like this. So we are already able to solve classification tasks using methods like count vectorizer, bag of words model, word to vec models, and in the deep learning stack we can use RNNs, LSTMs to do this kind of sentiment analysis or basic classification. So these are all solved problems. We have been doing this for decades now. There's nothing new. But what we have seen is with large language models, because these are pre-trained models and because they are so powerful, we talked about that idea in the last session, like meta learning, remember, zero shot learning. Because they are so powerful models, because they have such a good rich understanding and context of things due to the zero shot learning capabilities, generally they tend to perform better in these tasks compared to the traditional architectures. And that is exactly the workflow that I'm presenting, how to build this kind of an application. So initially we'll have the whole data. The data is the complete data that you will have, which consists of the input output combinations, right? And remember, this is the traditional machine learning discussion that we were having in the last session. So how does the machine learn? How does the model learn? The model learns from the data that you provided. If you don't give the data, the model will not be able to learn. So machines also learn from the historical data. Machines learn from whatever data that you provide. So for the machine to understand that given a review, what is the sentiment, you will have to teach it first. You will have to teach the machine with lots and lots of labeled examples. So you will have to provide lots of examples like, okay, this is the review, this is the sentiment. This is the review, this is the sentiment. Let me write it down. Maybe that will be better to relate to. So what you can do, this is your data, and the data will be, you will have a review and you will have a sentiment, right? So I'll just write it this way. There'll be some X and there'll be some Y. There will be some X and there'll be some Y. So X is the review and Y is the sentiment. Okay. And this is the label data. This is the data that you will train your language model on. Not exactly training. This is again something called meta learning that happens. I told you already that LLMs are already pre-trained. You don't have to explicitly train it, but with some sample data, you can basically include these examples as part of your prompt. That is what I basically meant when I said training. So you will give the machine lots of this label data, review sentiment, review sentiment, review sentiment, so that the machine is kind of able to understand that given a particular review, what is the expected sentiment for your company. Something very similar to what I was showing you as an example yesterday. Yesterday, remember when I was discussing few shot prompting, I discussed the exact same use case where I said that you will give the machine lots of labeled examples. Okay, lots of labeled examples. And that's exactly what we do. Okay, so you take the whole data and you keep aside some percentage of your data for few shot. I'll call it few shot. And the other percentage of your data is gold example. This is like the test data. Usually the ratio is somewhat like this, 20%, 80%. I'm just giving a ballpark figure. Okay. So unlike traditional machine learning, where some of you would have worked on it, you're coming from that background. So traditional machine learning, we always do a 80-20 or a 90-10 split, right? So we actually try to take maximum amount of data for training and very minimal for testing. But in large language models, in LLM applications, is kind of the reverse. We actually take a much more percentage of data for testing or gold and very few percentage of examples for few shot. Now, what is the reason? Because remember, here we don't have to train the LLM model from scratch because the LLM model is already pre-trained. It's a very powerful pre-trained model that we have. The large language model that we have right now is already a very powerful language model. It's already a pre-trained model, and we do not have to train it from scratch. We do not have to train that model from scratch. That's the idea. We don't have to train that LLM model. We don't have to train that language model from scratch. So that is why, even with some examples, it will be able to learn. Even with few examples, it will be able to do very well. So that is the whole idea. So you take the whole data, you split the data into few shot and gold. So 20% of your data approximately is few shot. 80% is what we refer to as gold examples, and gold examples are like your test set. This is like your mock question paper. Okay, so this is what you will evaluate the model on. The format is exactly the same. Okay, here also you have something called X and Y, and here also you have something called X and Y. The format is not different at all. The format is the same. You have simply taken this data and split into 20% few shot. This is what you will use to kind of fine tune your LLM in terms of giving a good prompt. And this is what you will use to evaluate your prompt. Okay, so after the prompt is built, this is what you will use to evaluate. That, okay, when the new review is this, what is the sentiment that the LLM is predicting? And now we will see the predicted sentiment with the actual gold sentiment. Gold examples are like the think of it like the final test data that you will evaluate the model on. So this is a bit of a new part that we are discussing now, how to evaluate a language model. All right. So these are your text label exemplars. Exemplars are nothing but the few short examples. There's another term called exemplars that we use, and this is how it will look like. So text is your X, and label is your Y. I think we are already clear on this. Okay. This is now going to be the text label exemplars. You will combine this with your system message. Mind you, there'll be a system message that you will have to also write, plus parameters, because there'll be prompt parameters like temperature, max tokens, top P, all that. Okay. And these are your few short examples. Okay. And what is the prompt now? The prompt is a combination of your system message plus your text label exemplars. So let's say there are two text label exemplars, U1A1 plus U2A2. This entire thing is basically part of the prompt. Okay. I hope everybody is able to get a sense of this. So you can see that when we design the final prompt is a combination of your design system message, whatever system message that you designed, and the few short examples. So in this case, I can opt to decide how many few short examples I take. So here, let's say if I take only two few short examples, two few short pairs, so then my entire prompt will look like system message plus U1A1 plus U2A2. And these two pairs of user assistant examples are basically used to give some kind of direction in terms of how the prompt should behave, how the LLM should behave. Okay, so this is what is used to fine tune the behavior using few short examples. Okay, so once this is done, that's your final prompt, and you will have a new user message, right? So this is how you design the prompt. Now the important part is there are a couple of variables here, right? There are a couple of variables here. The variables here are the system message itself, because there are different ways we can design the system message. The prompt parameters, there are different ways we can decide what values the prompt parameters should have. So we can set different values for the prompt parameters. And also, we can also decide what kind of text label exemplars we should have. Even this is a hyperparameter. You can also choose how many examples you should have. Should you have 2 examples, 3 examples, 5 examples? So you can decide how many examples you want to have. How many text label exemplars you want to have, you can actually choose that. So even that is a hyperparameter. You can decide how many examples you want to have effectively. So what you do is, after you try out all the different things, you will, let's say you have a sample prompt. What you're seeing on your screen is a sample prompt. You have designed a system message. You have designed, let's say, two few short examples. You have decided what the values will be, and that's your prompt. And you have decided some parameters. So that's your complete prompt that you have. Now, what you will do is you will evaluate the prompt. This is the most important part. Okay, you cannot build LLM applications if you do not evaluate. You will only be able to know the performance of your model if you evaluate your model on some unseen data, on some test data. And that is exactly what gold examples are meant for. Gold examples are meant to evaluate your model on unseen data, which is similar to a question paper. And you want to see how that model or how that application is performing on that question paper. So whatever prompt you designed, now you take the gold examples one by one. So this is like the X. Again, this is like the new user input. I'll call it U new. Okay, this is the new user input, which is the X. So you take the new user input, you combine that with the whatever the original system defined prompt that I had, which is a system message plus a few short examples. And now you take U new, that U new. And this is what becomes a final prompt. You make the API call. This is the API call. We did all this before. We can invoke the chat GPT, the GPT-4 Omni model, and the model will give a prediction. It will give a predicted label, and the predicted label will be what is the sentiment. Okay, it will give you some kind of a predicted Y. I'll call it YP. And now we will simply compare the YP with the Y actuals. Because remember, we already had the gold examples. We already knew the actual sentiment. So the actual sentiment is known. So now you take that new user query, like you take some sample review, and with that you make the LLM make a prediction. The LLM predicts that okay, the sentiment is positive or the sentiment is negative. This is YP, and now you simply compare the predicted sentiment with the actual sentiment, and that is how we get an accuracy score. Okay, so see how we can actually design a prompt. We can design a prompt, and when I say design a prompt, I mean to say design a system message, design your few short examples, design your prompt parameters. So design all of those things, and then you can evaluate the quality of your prompt. So after you design all those things, you can now evaluate the quality of your prompt. You can evaluate the quality of your prompt by measuring an accuracy score, and then you can try out different methods. So let's say you now try to change the system message. So now you decide, let's say you got an accuracy of 80%. I'm just giving a ballpark number, okay? Let's say you got an accuracy of 80% when you did this, okay? So you got an accuracy of 80% when you did this thing, okay? So now what you do, you change the system message. You make some tweaks. You make it a longer system message. Or let's say you try a different prompting technique like chain of thought prompting. We talked about COT prompting in the last session. So you do something called COT prompting. You try to incorporate more details in the prompt. You try to make it extremely detailed, extremely methodical, step by step, reasoning based instructions you're giving. You change the system message completely. You change the prompt parameters. Let's say increase the temperature value a little. Okay, so make it a bit more variable. Outputs to make it a bit more variable. Okay, let's say you change some other settings. Okay, you change some other parameters in the thing. And also you try to incorporate more few short examples. You give more examples, not just U1, A1, U2, A2, not just two pairs, but you give, let's say, 7 pairs. Because the more examples you give, the more data the language model has to tune itself. The more variety it is seen. So more data is always good. Not always, not all the time. You need to have too much data, but more data is definitely generally always good. So the more few short examples you give, generally, it will be able to fine tune better. So let's say in the next iteration, I give more few short examples, better system message, better parameters. And now I use that to do the prediction. When I give a new user input, the model will predict some sentiment. And this time, the predicted sentiment is very close to the actual sentiment. And you are getting, let's say, close to 99% accuracy. So this is how you compare prompt templates. This is basically what we are trying to do when we are designing applications. So we try out different templates. We try out different methods. And then we have some kind of a gold example or some kind of a test set, which we evaluate our language model applications against. And if we get a high accuracy, that's the solution that we take. This is the approach that we generally follow. And this is what we do for the classification task.